welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. BTDT stands for Been There, Done That. That's how you need to be prepared for actuarial exams. You should study for a 10 and study so that every time you look at a problem on the real exam, you can say to yourself, been there, done that, so that you know what to do, because there is no time for thinking on the actuarial exams. Thinking is the last resort of the unprepared. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM on financial mathematics. A 1,000 par value 30-year bond has an annual coupon rate of 7% paid semi-annually, which really means 3.5%, half of 7% paid per half a year. After an initial 10-year period of call protection, the bond is callable immediately following the payment of any of the 20th through the 59th coupons. If the bond is called before payment of the 40th coupon, the redemption value is $1,250. If the bond is called immediately after the payment of any of the 40th through the 59th coupons, the redemption value is $1,125. So there are really two different periods for the bond being called because of two different call prices. If the bond is not called, it will be redeemed at par, so at 1,000, because it's a 1,000 par value bond. To ensure that the bond will provide at least an annual nominal yield rate of 5% convertible semi-annually, which really means 2.5% per half a year, it must be assumed that the bond will be called or redeemed immediately after the payment of the nth coupon. Calculate n. And here's the solution. During the first period when the bond can be called, its modified semi-annual coupon rate is 1,000 times 3.5% divided by 1250. Remember, the modified coupon rate refers to coupon divided by the redemption value, and in this case it's the redemption value is 1250 if it's called, so it's 2.80%. And this is more than the desired semi-annual effective yield of 2.5%. If the bond is called during this period, the bond sells at a premium, and thus the worst case for the bondholder is the earliest possible redemption, because the bondholder is getting 2.8%, but wants 2.5%. This is very nice. And the worst possible scenario is the bond is called at the very beginning, so the bondholder loses all those coupons that are effectively at 2.8%. That's why the worst case is at the beginning. The price today at 2.5% yield, if called at that time, and 2.5% because that's the yield that the bondholder wants, at that time, so the earliest possible redemption during the first period when the bond can be called is 35 A angle 20 at 2.5%, plus 1250 times 1.025 to the negative 20, and that's approximately 1,308.46. During the second period when the bond can be called, its modified semi-annual coupon rate is 1,000 times 3.5% divided by 1125. That's actually even better, 3.11%. And this also is more than the desired semi-annual effective yield of 2.5%. The worst case for the bondholder is again the earliest possible redemption, because that basically cancels those high coupons later on. The price today is 2.5% yield, and at 2.5% yield. If the bond is called at the earliest possible redemption time during this period, is 35 angle 40 at 2.5% plus 1,125 times 1.025 to the negative 40, so that's approximately 1,297.58. Of course, this is just the basic franc formula, and you can use a calculator, just find the price of the bond by using the yield of 2.5%, payments of 35, and the redemption value, the future value of 1,125. Finally, if the bond is not called, the price today is at 2.5% desired yield is 1,309.08. That's 35 angle 60 at 2.5% plus 1,000 times 1.025 to the negative 40, and that's 1,309.08. The price that assures the desired 2.5% yield is the lowest of the three, because any higher price will result in a yield lower than 2.5% during the second period when the bond can be called. Thus, the worst case scenario that the bondholder must protect himself against by paying no more than 1,297.58, that's the price that corresponds to the second period of call, is this bond being called at the time of the payment of the 40th coupon, which is the beginning of that second period. And that's what we're looking for, and that's answer C. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.